Howdy folks, welcome back. So in this video, I'm just going to quick go through the second practice quiz and again just show you how I go about solving the problems. Again, I recognize it's by no means the only way, and in some cases it might not be the way that makes the most sense to you. Again, as long as you end up at the correct solution at the end, if you do it a different way than I do it here, that's fine. Always excited to learn new techniques there. All right, so the first question is dealing with factoring a quadratic polynomial into linear factors. All right, so just factoring a quadratic polynomial. All right, so again, if we have a leading coefficient that's not equal to 1, so in this case we have a leading coefficient of 6, how I would go about doing this is I would use this one again as a slide and divide technique. All right, so the slide and divide technique, again, how that works is you just take your leading coefficient and you're going to slide it, and when you do that, you're going to multiply it by a constant term. All right, so we end up with x squared minus 5x minus 6 times 6, which would be 36. All right, and then we're just going to factor this expression. All right, now if you have leading coefficient of 1, then it's really convenient because your factors are both going to have just your variable. All right, and now I'm looking for two things that when I multiply them together give me negative 36, and when I add them together give me negative 5. All right, so again, you need to figure out what your factors are, so what numbers you can multiply together to get 36. So you have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. All right, and since we have a negative number here, one of these has to be positive and one of them has to be negative. All right, so looking at these options here, if I take 9 minus 4, I end up with 5. So if I take 4 minus 9, I end up with negative 5. So those are going to be my two constant terms in each of my factors. So we're going to have positive 4 and then negative 9. All right, so once you have it factored, you're going to divide by what you originally slid across. So in this case, we're just going to divide both sides by my original leading coefficient there. And I'm going to simplify. So here we have a common factor of 2 that goes into both 4 and 6. So we're going to have x plus 2/3. And here we have a common factor of 3 because 3 goes into 9 and 6. So that's going to be x minus 3 over 2. All right? And then if you have any fractions, what you're going to do to factor it is just going to take your denominators and you're just going to bring them out in front of your x term. So you have 3x plus 2. And we have 2x minus 3. And again, if you're curious as to whether you have the right answer or not, these are one of those ones that are pretty convenient to check. So you can just expand this out. So you end up with 3x times 2x. So that's going to give us a 6x squared. And we have minus 9x plus 4x. That's going to give me negative 5x. And then we have negative 6. So that's going to be the negative 6. So yeah, so this is the factored form of the quadratic expression there. All right. Next one here is dealing with solving a quadratic equation. All right, so there are several different methods that you can use to solve a quadratic equation. So if we have something like this, most of the time what I would try to do, if we have something involving my variable raised to the second power equaling a constant term, then you can use the square root property. All right, so to use the square root property, you can just take the square root of both sides. And when you do that, you just have to account for the plus or minus. So here, when we take the square root of something squared, the squared and the square roots are going to cancel out. So we're going to have x minus 3 here. And then we have plus or minus square root of 16. So then we can get an x by itself by adding 3. All right, so the square root of 16 is going to be 4. So if we take positive 4, we have 4 plus 3, so that's going to be 7. And if we take negative 4 plus 3 is going to be positive 1. All right, so yeah, so that's one way you can do it. Another way is you can use the zero factor property. So we can expand this out. So when we take x minus 3 times x minus 3, so you have x squared minus 3x minus 3x plus 9 equals 16. So you have x squared minus 6x And then we can subtract a 16 from each side. Minus 7 equals 0. And then we can factor this expression here. So to do that, we're looking for two things that multiply together to give me negative 7 and add together to get negative 6. So that's going to be negative 7 and positive 1. All right, so if you have a factor, so product equaling 0, to solve this, you can just set each factor equal to 0. So here we can add a 7 to each side. Here we can subtract a 1. So we end up with x equals positive 7 and negative 1. Which, looking at this, I think I made an addition error back here. So you have negative 4 plus 3 should be negative 1. All right. So yeah, so again, regardless of which method you choose, you end up with the same answer at the end. You can also use the quadratic formula, which we're going to use the quadratic formula for this next one, so I won't spoil that here. But again, regardless of which method you choose to use, you should end up with the same answer. So there's nothing that requires you to use a specific method to solve it. All right. So the final question here. So we have an astronaut on the moon throws a baseball upward. The astronaut is 6'6", so 6.5 feet tall, and the initial velocity of the ball is 30 feet per second. The height s of the ball in feet is given by the equation there, where t is the number of seconds after the ball was thrown. How many seconds will it take for the ball to return to the surface? All right, so yeah, so in this case, to return to the surface, again, s represents the height above the lunar surface. So when it returns to the surface, it's going to be 0 feet above the surface of the moon there. So we have 0 equals negative 2.7 t squared plus 30t plus 6.5. And most of the time when we have decimals, a lot of times factoring doesn't really work out necessarily all that well. Also, since we have a squared term and a linear term, so we don't just have a term involving my variable squared and a constant term, so a term that doesn't depend on my variable, we can't use the square root property directly. We can do completing the square to convert it to a problem where we could use the square root property, but most of the time that tends to be a long and tedious process, especially when we have the quadratic formula that we can use there. All right, so again, the quadratic formula is we have t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so one of the first things that I would do when I get the quiz is I would write this formula on the top of the quiz. That way I have it, because again, we could use it for this one, we could use it for the next one. So you can use it for 2 out of the 3 of the questions right from the get-go there. So yeah, so just because my memory is terrible, so I don't really want to chalk anything up to my memory. I would probably write it down again the minute I get the quiz. That way I have it there. All right. Anyway, so now it's just a matter of figuring out what our ABCs are. All right. So A is going to be whatever your leading coefficient is. All right. So in this case, my leading coefficient, or the coefficient in front of the largest exponential term, so is going to be negative 2.7. C is going to be my constant term, so a term that isn't attached to my variable. And then B is going to be the leftover, so B is going to be the 30. There. All right, so then it's just a matter of plugging these values into my quadratic formula. So we have t equals negative b, so negative 30, plus or minus the square root of b squared, so that's going to be 30 squared, minus 4 times a, which is negative 2.7. And c is going to be 6.5. And all that divided by 2 times a. All right. So just doing some of the arithmetic here. So we have negative 30 plus or minus the square root. So 30 squared, that's going to be 900 minus 4. This is where I'll get on my calculator. So you have 4 times 2.7 times 6.5. So you have minus 70.2. All divided by 2 times negative 2.7, which would be negative 5.4. Negative 30 plus or minus. So you have 900. Yeah, this should be a negative times a negative, so this should end up being positive. Yep. So plus, so square root of 970.2. I guess I don't need my calculator for that. Divided by negative 5.4. All right. So if we take negative 30 plus square root of 970.2 and divide that by negative 5.4, we end up with negative 11.32. And if we take negative 30 minus the square root of 970.2, and we divide that by negative 5.4, end up with, we end up with positive 11.32. All right, so when I take negative 30 plus the square root of 970.2 and divide by that negative 5.4, and with negative 0.21. All right, so I must have made a calculation error previously. All right. And again, these represent times. All right, so again, when we solve our equation, we have to ask ourselves 2 questions. The first question, does the answer make sense? Does it fit the physical constraints of this problem? In this case, again, the main thing we need to worry about is if we end up with a negative number, because we can't have a negative time value. So there's no time travel in these types of problems. So there's no police box or time turner or 1985 DeLorean with a flux capacitor. There's no mention of Superman flying around the earth super fast in reverse to turn back time. There's no mention of the Flash and using his flash powers to travel back in time in the problem. So in this case, again, we can kind of just ignore the negative number. So what we're left with is 11.32 seconds there. All right. So yeah, so again, that is how I go about solving problems. Again, I recognize this is no means the only way, and in some cases it might not be the way that makes the most sense to you. But hopefully, if you're curious as to where to start, hopefully that gives you a little bit of idea. Thank you all. Have a lovely day, and I'll talk to you all later. Bye now.